So today we're going to be taking a look at doing a little fun Christmas project, and we're going to be programming noughts and crosses on a Siemens PLC. Why would you want to do this? I don't really know, but it's Christmas and we can, so let's give it a go. Maybe we'll learn something along the way. So in terms of setup, I have already got my network set up here. I've got a physical PLC being attached. It's a 1500 PLC. An ET200, and then I've got a virtual HMI which I'm using here. I've already set up this connection. I'm not going to go through that now. You should be able to do that. There are plenty of other tutorials that show you this basic setup. In terms of stuff that I've already got programmed here, I have just an empty step sequence. This is where we're going to be writing the majority of our program. It's empty for now, so that's fine. This is a good starting point. And then I have a HMI set up, and I've just got a blank screen set up here on my HMI. I also have another screen here, the solution. This is the final project, but don't worry, we're not going to jump in there yet. Maybe I'll give you a sneak peek. Here we go. Oh, that's what it might look like when it's finished, but we'll put it away for now and we'll come back to our root screen. Okay, and I have also got one other database which I've set up just to help us to begin with, but we will explain this as we go. So without further ado, let us crack on with making our noughts and crosses project. We're going to start actually with the HMI screen itself and thinking about how we might go ahead and do this. So in a game of noughts and crosses, we're going to want to have 1, 2, 3, 4, 5, 6, 7, 8, 9 different cells. And each one of those cells essentially can be represented by either a blank space, this is nowhere no one has played yet, or a 0, or a cross, so a naught or a cross or empty. So what we're going to be doing is we're going to be creating a button that can be represented by one of those 3 states. So let's look at how we can do this. We can drag in a button, and I'm going to start just by coming across to the properties of my button here. And I'm going to start by looking at the layout of it. And I'm going to put it at 100, 100, 100, 100. So this makes us a square button that we can use. Now at the moment it says text on it. This is not very good, and it is definitely not our noughts and crosses. So in order to get this to work, we are going to use something called a graphics list. So I'm going to change the mode of the button to graphic. I'm going to change it to graphics list. And then we're going to need to create a graphics list that we can use. Now, I already have one set up here, but let's look at how we do this from scratch. So if we come across on the left-hand side here to text and graphic lists, we get text list by default. We can switch at the top over here to graphics list. And here is my list. So I've made a list called XO list. And we have here 3 different values. We've got 0, 1, and 2. And so 0 has just a white empty space. 1 has a round space, a 0, and 2 has an X space. So I've made these little graphics basically, just 3 little pictures, 100 by 100 pixels wide. So we have these 3 different symbols. That's great. What we're going to do is we're going to go back to our root screen, and we're going to come over here and we are going to attach the graphics list. Great. So now our button is white by default because it has no tag assigned to it. So the next thing we need to do is attach a tag. And we have over here our tag that we can attach, and we can start looking for which tag we want to attach. Now, I mentioned already that I have set up something advanced, and I have here this database XO. And in this database XO, we've got 3 different arrays, but for now we're just going to focus on the first array, which is this XO states. So this XO states is an array from 0 to 8 of integer. And so we start at 0 and we go to 8. And this is going to be the 9 different squares on our noughts and crosses board. And so, of course, this first square in the top left-hand corner is going to be XO state 0. Let's have a little look at that, shall we? So if we come back to our root screen and we tag here, we're going to come across, we're going to tag XO states 0. Done. And now that should work. So when the value is 0, it'll be empty. When it's 1, it'll be the 0, and then or the naught, and then when it's 2, it'll be the X. We can simulate this hopefully to see if it works. So if I download into my PLC just to make sure that it's got the current project in, and then we boot up our HMI, our virtual HMI, and while that's loading, I'm going to load up my XO states and begin to monitor that. Okay, I've got a couple of leftover things from when I was testing earlier. Let's restart the PLC just to make sure that they all clear out. There we go. And here we go. So I have empty screen over here, empty box. And then if I change the value here, something like 1, actually if we put this over on one side, we should see, there we go, we have the naught displaying on our HMI. And if I change it again, so if I change it here to 2, then it updates. If I change it back to 0, it updates again. So we have the display part of this HMI working. This is really good. What about the buttons? Okay, because the buttons are the thing that we need to do next. So let's go back to our root screen and we'll come back to our button that we've put in here and we'll go over to our events and we're going to need a press and release event. So on the press, we're going to do set bit and we're going to assign the second set of array here. So we have here the states array, but we also have a buttons array. So I'm going to use the buttons 0 array here. As a reminder, this is in our EXO database. So we have EXO states. This is going to represent what gets drawn, the 0, 1 or 2. And then we have our EXO buttons array. This is again an array. It's just a 0 to 8 of Boolean. It's either true or false, and it's going to represent when we're actually pushing the button. So that's what we're tagging here on our button. So we come across, we have set bit, and then when we release, we're going to have reset bit. And we're going to attach buttons 0 here as well. Perfect. Okay, so what I'm going to do is just save my project and I'm going to close the HMI because we've made some changes and I'm going to reopen the HMI and I'm going to come back to the database that I'm monitoring. Here we go, with our buttons on it. And so hopefully what we will see now, if we put this in the right place, there we go, here's our buttons. As I click it, there we go, we see that top one changing, right? So as I click the button, that's what I'm doing here, click, perfect. These power tag messages get annoying after a while. So we click that, and we see that it's changing. Perfect. So I think we understand how this works, right? We have our different states for our 9 different buttons, and we have our different tags for our 9 different buttons. What we're going to do is we are going to go ahead and we're just going to basically copy and paste this 9 times until we get to a point where we have everything added to it. So let's go ahead and do that now. We're going to come to our root screen. We're going to click that. We're going to copy and paste a button. We're going to move it onto the next location. We can use the layout to make sure it's in exactly the right place. Actually, I got it perfectly there. 200, 100, 100, 100. Perfect. And then we're going to have to go through to our general. We're going to have to update it so that this is now looking at states 1. And then we're going to go over to our events and we're going to update it here so that we're setting and resetting button 1 as well. So we update all of those things here. Okay, we're going to go through and do that for all 9 buttons. I'm not going to make you watch it. What I'm going to do is skip ahead until I have it done. Here we go. 1, 2, 3, skip. And just like that, we have a absolutely perfect grid, which has all of our buttons in. We've got all of the buttons here listed from the first one down to the last one, and they're all tagged. So if we now launch this again and we just save our project and then we run our HMI, we should see that we have 9 possible buttons that we are able to press. There they are. Look at that. Absolutely perfect. Okay, so now let's start writing some logic. We're going to start in our sequence database, and we're going to think first a little bit about how this is going to work. So the first thing that we're going to want to do here is basically to make sure that we have a placeholder step. I always like to have a placeholder at the beginning of my program. And then we're going to come into just put a semicolon there so the linter doesn't fail. Okay, we're going to come into step 10. And so what we're going to want to do in step 10 is basically make sure that we check whether or not anyone is pushing any of the buttons. So in order to do this, we're going to basically loop through all of the different spaces that we've got. And so to do that, we're going to need a little counter. I'm going to call it grid counter, just like that, or maybe grid count is slightly easier. So we have grid count. And I'm going to say here that grid count is going to go from 0 to 8, so all the way through our grid. And while we're going through this grid, what we're going to need to do is check whether or not the button has been pushed. So we're going to need an if statement here. We're going to say, oops, not of, sorry. If our XO buttons grid count, so if the button has been pushed, then what we're going to want to be doing is jumping on to the next step for now. So let's jump on to the next step. Oh, another off. If. There we go. Okay, so this will loop round through all of the buttons within our grid. We are going to want to make sure that we know which player is currently playing. Okay, so we're also going to need something to keep track of the player. And the player is going to be either player 1 or player 2, because this is going to be a 2-player game. So at that point, what we are going to do is the player is going to alternate between each one of these 2 steps. We'll set up the logic for that later. But for now, what we're going to do is we're going to say that our XO button, XO states grid count is going to be assigned the value of player. Perfect. So we can imagine in the beginning that player is 1. We've set it up here so it's the default 1. And this means that it will loop through the buttons, and if any of the buttons get pushed, then it will assign the value of the state to the player. So the player will change and we'll jump into the next step. In the next step, we need to make sure that the person has actually kind of released the button, because we don't want it to kind of do stuff forever. We want a click and then we want a release. So in the next one, we are basically just going to say that if not XO dot XO buttons, here we go. We're going to need to know which one was changed here. So let's add a changed integer. And we're also going to set this here. So we're going to say change is equal to grid count. So, okay, we've assigned which one is changed. And then here we're able to just check change. And after this, we can jump over to the next step. So we'll go step 20. Perfect. Okay, so we have our placeholder here at the beginning. We're looping through, checking if any of the buttons have been pushed. If the buttons have been pushed, then it will set it to whatever the value of player is, and then it will jump into the next step, which is step 20. And so what we could do in this next step is we could do this logic to allow us to switch between the 2 different players, right? So we can say if player is equal to 1, then we need to update player to be assigned the value of 2. And else, then we want the player to be assigned the value of 1. Perfect. Assigned the value of 1. Very good. And so now what we're going to do is just jump that back to step 0. And we will make step equal to 10. Just so that it loops round properly. Okay, so we have enough here that this should allow us to test the actual kind of changing of stuff. There's no way of resetting anything yet, but it will allow us to check whether or not stuff is working. So what we're going to do is just download to the PLC. There we go, PLC downloaded. And we're going to come back to our HMI and we're going to simulate it. There we go. So what we should be able to do now is click and we get a 0, and then when I click on the next one we should get an X. There we go, and if I click on another one it should be a 0, and if I click on the next one it should be an X. Too many power tags. Okay. There we go. So this is good. We can click around and we can click on all of these and they all change. This is very good news. We're getting somewhere. So we have our switching logic. We don't have a reset logic yet though, so it might be a nice idea to do that now to begin with, and obviously we can do that within our 0 step. Make a good place for it. So what we're going to do here is have our reset logic. And so for our reset logic, we are just going to basically loop through all the states and put them back to 0. And then we're also going to loop through all of the buttons and put them back to 0. So we're going to need integer. We'll just call it I. We'll use this as our loop counter, essentially. And I have a little bit of code. I'll just copy and paste in to avoid me writing it out. There we go. So we're looping through all of our states and we're looping through all of our buttons. We're writing all our states to 0 and we're writing all our buttons to false. Okay. So this just makes sure that when we do our reset process, everything gets zeroed out. It's nice and easy. Now, because this is going to reset everything, it means at the end of the game, we don't want to jump back to 0. We want to jump back to 10, because otherwise there's a risk that it will reset every single time. Well, it's not risk. It will reset every single time. And so we're going to need to make a small modification to our root screen, because what we're going to want to do here is to add a reset button. And this time I will just use a standard button. We're going to call it reset. We're going to come to properties of this button. We're going to go to the press state and we're going to do set tag this time. And we're going to simply set the program blocks sequence to step to 0. There we go. So we have this ready to go. And if I download my PLC program again and reinitialize and relaunch my HMI, it should now launch with a lovely shiny reset button. Here we go. And so now I should be able to play 0x, 0x, and then I can reset and it all goes away. Perfect. So that's working exactly as we intended. It would be nice, I think, if we could see whose turn it was. So in order to do this, I'm just going to copy one of my buttons over here. I'm going to come to the properties of it. I'm going to remove the actual button, like press stuff, the set bit, because we don't need that. We just want it to be an indicator. And we are going to tag it across to my sequence player. Okay, so now this will show the current player. So maybe we can add a little label here saying next turn. Oops, capital's on wrong. Let's try that again. Next turn. There we go. We'll just put that there. So now if we launch this again, hopefully what we should see this time is it should show us whose turn is next. So it shows us 0, and it changes, and then it shows us X, and it changes, and it shows 0, and it changes. Perfect. So we can see exactly whose turn is going to be next. Okay, so we have a functional game here. This is good. We could play it and we could work out who's won just by looking at 3 zeros in a row, 3 noughts in a row. But it would be really nice if we could get the system to recognize this. So this is where we're going to look next in our code. Okay, so we have this excellent code here so far that splits things around. What we're going to need to do next is basically to check if there's a winner. And we're going to need to do this before we switch the player, right? So I'm going to bump this down to 30. And I'm going to put here a new step 20. And this is where we're going to be check if we win. Okay, so how do we need to do this? We need to check basically whether or not we have in a row 3 1s or 3 2s. We want to make sure that we're not checking for 3 zeros, because when the game starts, there will be 3 zeros everywhere, right? And really the easiest way of doing this is just 8 if statements. But we are going to have a little helper function that we're going to use to help us here. And so I'm going to start by creating a new function, and I'm going to call it check win. There we go, check win. Now our check win function is going to have 3 inputs. We're going to call it input A, input B, and input C. So this is going to be like 3 different positions that we want to check in a line, either horizontally or vertically. And these are all going to be integers because it's going to be the values, either 0, 1, or 2. There we go. This function is going to return a value, so it's going to return a Boolean, and then we just need to write our simple logic statement here for this. So all we're going to do is we're going to say that check win, the Boolean output value, is going to equal if A is greater than 0, so if the first one is greater than 0, and we need to check if the first one is equal to the second one, and we also need to check if the third one is equal. The second one is equal to the third one. And that's it. So we can see the logic here. We're basically making sure that A is not 0, okay? Because if A is 0, then obviously it's not a line. We're then also checking that A equals B, so the first two match, and the second two match, and therefore we can also conclude automatically that C must equal A, because if A equals B and B equals C, then perfect, they must all equal the same thing. So A is not 0, and they all match, and that's it. That's our check when function. So let's come back to our sequence here, and let's put in the first one here. So we are going to want to do something like this. I'm going to copy in here the solution just to save us a little bit of typing. Okay, here we go. So this is what we want. So we are checking if there is a win between boxes 0, 1 and 2. This is our first horizontal row. And if there is, then we are going to set the line to be true. What do I mean by the line? Well, you noticed we have a third array here, XO lines. We have 0 to 7 because we have 8 possible combinations for winning. And so in our screen, we're going to want to draw here a nice red line. We're going to take a line like this. We're going to come across. We're going to make it nice and big. We're going to make it red. And we are going to add an animation and change the dynamic visibility. And we are going to tag it with the XO lines 0. And it's just a single bit, it's either true or false. Okay. So this is our first horizontal line, so it's going to come across like that. Okay, so this is the first win, and essentially if we look here at the sequence, we will see we're checking if there is a win across these, and if there is, then perfect. We can set here the lines to be true, and maybe what we can do is we can have a new statement here, so we can have winner, which will make us an integer, and then all we will do is we will add this little line here, where we will say winner is equal to player. This will just let us track whether or not there was a winner. So this whole little section here works for the first line. So we can very easily carry on, and if I copy in my next 2 lines of code here, there we go. So now we're checking whether or not we've got a winner on the second horizontal line and on a third horizontal line. And so I've got here my lines 1 and lines 2. And so of course I would need to come back into my root screen. I would need to take my line, duplicate it, put it here, come across and update it to lines 1 and again for lines 2, and then I need to do the 3 vertical ones and the 2 diagonal ones. So I'm not going to do that now. I'm going to clap my hands and just like magic it will appear. 1, 2, 3, and there we go. We have our lines drawn on top of our root screen. This is very good. So now we need to just come back in here and fill out the rest of our sequence. So we've done our rows. All we're going to do now is add in our columns and our diagonals. There we go. We have our columns in and we have our diagonals in. So finally, what we're going to need to do here is at the end of this step, we need to check whether or not there is a winner. So we're going to say if winner is greater than 0, so if a winner has been found, then we will jump to step number 40, which will be kind of a step that does nothing. And if not, then we carry on playing and we do jump to step 30. And that should give us everything that we need in order to get this game to work. The only other thing we're going to need to do is to reset the lines and also to reset the winner status. So we can add that up to the top of our code here. We make sure that the lines are false, 0 to 7, and we reset the winner. Otherwise we can't play the game. So let's download this into our PLC. We will update. And then we will come across here to our root screen and we will simulate. And hopefully we should have a fully working game here. Let's take a little look. Okay, so Naughts, then crosses, then Naughts, then, oh, too many power tags. Another cross, finally another Naught. There we go, and we got the line across it. And because we're now in step 40, the game is frozen. We can't carry on. We can't play anymore. The Naughts win. We can reset, of course, and then we can go again. So we can do Naughts. Should we see if we can get a cross to win this time? Let's see. There we go, and our 3 crosses. So the only thing left to do is to embed a little bit of festive cheer. And in my solution, I added some fairy lights because it is Christmas. Here we go. Glasses on. And what I will do is I will make available this little Christmas graphic for the background, and I will make sure that we are able to play it with this little Christmas go. Here we go. There we go. We're all up and running. We can reset and we can go again. Oh, it looks like my my tag here is not quite working on my final solution. Let's come across and make sure that we have the right tag on it. Probably I did not have a tag set up. Here we go. Because we made the player tag, didn't we? We have to change it. Here we go. There we are. Beautiful. Christmas Naughts and crosses. Wonderful. Here. Naughts are going to go here. And crosses. It's a win. It's a win for crosses. Well, I hope you've enjoyed this tutorial. Thank you very much, and Merry Christmas. And that's it. I hope you found this video useful. Please feel free to like and subscribe for more content coming soon.